Cyclotron is a device developed by E.O. Lawrence and M.S. Livingston in 1934. It is used to accelerate charged particles like protons and neutrons. This results in production of high energy charged particle. In nuclear physics, such energized particles are used to bombard nuclei causing nuclear reactions. A positively charged particle can be accelerated to high energy with the help of an oscillating electric field by making it cross the same electric field time and again with the use of a strong magnetic field. Two hollow half cylinders made of high conductive metals known as Ds are so placed that the straight edge will be face to face with a small gap between them. Now these two Ds are connected to two terminals of an alternating voltage source, an oscillator. It would help in changing polarity. If D1 is in the positive potential, then D2 will be in exact opposite, that is negative potential at the same time. In this way, they would be oscillating and an electric field would be created between them. One electromagnet is kept below the two Ds and one electromagnet is kept above the Ds. Bottom electromagnet will have north pole above and top electromagnet will have south pole below. This would create a magnetic field perpendicular to the direction of the electric field. This entire arrangement is sealed in a vacuum box. The two Ds create an electric field. The direction of electric field is horizontal. The direction of magnetic field is vertical. When we place a positively charged particle, which may be a proton or a combination of proton and neutron both, since D1 is positive, D2 is negative, there is an electric field between them. Now a force acts upon the charged particle and its direction would be the direction of E. Because of this force, the charged particle gets acceleration, and because of acceleration, the speed increases till it enters the D. Since D is an enclosed container, so the value of electric field is 0. So force becomes 0 and acceleration becomes 0. So inside the container there is no electric field, but there is magnetic field and its direction is north. The charged particle now moves perpendicular to the direction of the magnetic field. It experiences a force in a direction perpendicular to the plane containing V and B. This force provides the centripetal force and makes the charged particle move along a circular path of radius r is equal to mv upon q times b. The particle makes a semicircle and comes to the gap. The time taken is t by 2. Because if the time taken to complete one circle is t, then the time taken to complete semicircle would be t by 2. As soon as the particle comes to end, it is influenced by electric field. When the particle was born, its velocity was 0. When it enters the D, its velocity is v and it is constant because the magnetic field cannot change the velocity. The oscillator will change the polarity. When it comes out of D, it again comes under the influence of electric field. The electric field accelerates the charged particle to V1. When it enters D2, the velocity would remain constant. Now D2 becomes positive and D1 becomes negative. When it comes out of D, it again comes under the influence of electric field. The electric field accelerates the charged particle. The particle would now move from D2 to D1 because its velocity would increase to V2. When it enters D1 again, the velocity would remain constant because the magnetic field cannot change the velocity, but the particle would make a greater semicircle because it is coming inside the D with a greater velocity. When it comes out of D, it comes under the influence of electric field. Once again, the electric field accelerates the charged particle and now the velocity becomes v3. In this way, the particle moves in a circular path, and with each circle, the velocity of the charged particle increases. If the velocity of a charged particle increases, the radius of the charged particle would also increase. Finally, when the particle has no more space to grow in radius, it is thrown out through a window. With such a high velocity, the particle has high energy and it hits the target.